So welcome CityCon. We're really excited to be here. We know that we are close to the end of the date, so we really appreciate taking the time today to be with us here. So yesterday, Fatih announced on the keynotes that there are 2 new kids in the block in the CD Foundation. One of them is City Events, and the second one is Shipwright. And that's actually why we're here, so we want to speak a little bit about Shipwright. So maybe I can engage with a few of the folks that we're here, so you can help me by raising the hand if it applies. Does any one of you knows what is Shipwright? Have any one of you been using Shipwright to build container images? All right, that's cool, because today we're going to tell you, for the ones that doesn't know too much about Shipwright, I'm going to give you a little bit of context on what is Shipwright, how can you use it, and then we will also deep dive on what are the next things that are coming for the project. So let us introduce ourselves. I'm here today with Sascha Schwarze. He's an IBM developer, he's a Shipwright maintainer, and he enjoys playing beach volleyball.
And the person that just started the talk is Enrique Encalada. He is IBMer like me, Shipwright maintainer like me, and he actually took the 5K run this morning as he's training for triathlon.
Right. All right, so Shipwright, I will just do a quick recap on what is Shipwright. The first thing is that Shipwright does one thing well, and that is actually building container images. I typed this beautiful haiku today for you, and it goes like this. Shipwright is a simple approach, code, build tools, and instructions to build your image. So in Shipwright, or one of the aims of Shipwright is really to simplify the experience when building container images in Kubernetes cluster. Shipwright achieves this in an efficient and secure way. If you would like to use Shipwright, you probably want to ask yourself 3 questions. What you want to build, how you want to build, where do you want to actually push your image? So the what is really about the code. Where do you have your code? Is that in Git? Is that local source code? Then the how. And for the how, usually in Shipwright or in Shipwright idiomatics, we have custom resources as we run on Kubernetes. We have something that is called the build strategy. The build strategy is basically a resource that have a set of steps that will tell you how to build a particular container image. Under the hood, build strategies have different build tools such as Canico, Builda, KO, Paquito, right? So as a user, to answer the question how, you can easily just choose one of these build strategies that we make available for you in the cluster. On top of that, you can define different instructions. You are able to define the behavior at build time. Let's put an example. You require a build time to have an environment variable, so you can define that through the different Shipwright resources definitions that we have. At the end of the day, Shipwright is going to build your image, as I have in the last sentence of the haiku, but also is going to build and push an image to a container registry. Keep in mind that Shipwright is built on top of Tekton, so if you will do a deep dive in the mechanics of Shipwright, you will eventually find out that we generate Tekton resources such as a task run. Today, Shipwright is on an alpha state, and we, the Shipwright community, have been discussing on moving to beta in the next months. Shipwright is not only the technology, so Shipwright is also the community, and that will be my main focus on the next slides. Shipwright community is a community of doers, and as Fatih mentioned yesterday, Shipwright graduated to the CD Foundation as an incubation project back in August 2021. I can give you a little bit of the reasons why we did that. One of the reasons was we were looking for ownership neutrality, so the foundation was really like the best place to where we can put the project. In addition, it felt natural to be the CD Foundation, because in the CD Foundation, we already have projects such as Tekton, where we have interdependencies, and we could also boost our collaboration with different communities. In addition, being part of the foundation also have benefits for us, as in terms of visibility, we can get more contributors and eventually get more feedback on the state of Shipwright. Right, so let me just tell you a little bit about the Shipwright community, and then Sascha will go into more technical details or what is coming next for us. The Shipwright community, in my opinion, is unique. The Shipwright community is an open source software community that is focused on trying to improve the experience when building container images in Kubernetes clusters. There are 3 key things of this community. One is continuous improvement. That basically means as we move forward as a community, we have a lot of GitHub repositories. There is a lot of things that we need to work on there so that we can improve the state of the community. As good engineers, one of the key things is automation. We try to avoid doing a lot of the manual steps, and we favor automation. We have times where we have a lot of issues across multiple repositories, pull requests, and technical proposals, and that's where we try to shorten the feedback loop. The second thing is that Shipwright is really a sustainable community, and if you're interested in achieving that state, you probably need to have a specific set of things. For example, contribution guidelines, code of conduct. We invest a lot of time in documentation. So for example, if you go today to the Shipwright build repository, at a first glance, you will understand what is Shipwright, and you will also be able to use it in an easy way. If you are more interested on Shipwright, very specific details, you can just go to the extensive documentation we already have for users. The last thing is about culture. I think like the community will not work if we will not have three key things: trust and respect and inclusiveness. So today, folks in the community, on our weekly meetings, I think they feel comfortable to always, provide feedback, ask any type of questions, and so on. Right, so as this talk is actually what happened on the last year in Shipwright, I have some numbers for you. We still have low numbers in terms of what we have here, but the improvement or the increase is actually quite significant. So in the last year, we were able to ship 15 releases across the multiple Shipwright repositories. We saw an increase of more than 50% in terms of contributions. We have what is called the Shipwright improvement proposals. You can see this as cool ideas that the community are working on in order to enhance the Shipwright state. So we increased there with more than 70%. And also, all of these proposals are already implemented as part of the Shipwright API. The last thing, and now I will give back to Sascha, is we have today, or we announced today, 3 new Shipwright projects. That's the CLI, that's the Shipwright image, and that's the Shipwright triggers.
Thank you, Enrique. So let me spend some time discussing some of the core features that we delivered over the past year. The first 2 that I'm showing here actually make installation and use easier. So first of all, in addition to the traditional approach of doing a kubectl apply to install Shipwright build on top of your Kubernetes cluster, we now have an operator. So if you're used to installing things through Operator Hub, then you will find Shipwright there in the meantime since a couple of times. The nice thing there is, Enrique mentioned that we use Tecton under the covers, and if you use the operator, then it will automatically install Tecton for you in the right version. So that makes the installation a little easier. On the other hand, on the operator, there are different levels. We are just on level 1, so there's still enough to do. The second thing that I would like to highlight here is our CLI. So back a year ago, it had always been a pain to set up a build and get your build runs going because you had to work with Kubernetes manifests. And our CLI is greatly simplifying that experience, and I'm going to quickly show that in a video. I have to say something up front. The vendor of that software was so kind to introduce kind of a bug. You'll see it in a moment, but we'll get through it. So we are here in our CLI, and I'm running one command, which is the shp build create command. And when you see the things that go in there as arguments, then that's exactly what Enrique mentioned. So you see which source is being built, what is the strategy being taken, build kit in this case, and what is the output image, meaning where do we want to push the image to. And that's the bug. So the second command that comes here is shp build run. Actually, one of my favorite commands, especially with the ---- follow flag. So what happens here is that the CLI is creating a build run. It looks for the pod that is being created, and subsequently right away starts tailing the logs that are happening there. So it's just like as if you would run your build locally, you see live the progress, and if it would fail, then you would right away see where it actually hangs. And that's, really cool. So I love the CLI. it's much more easier to get things set up and run your builds. So let me come to a couple of features that we added to our build APIs over the past year. So if I look back 1 year, then we actually were not able to build certain sources. And the reason for that was that we were lacking certain parameterization. So to give you a few examples, we have one build strategy which is based on KO. So that's a tool to build a container image for your Go code. And there you need to specify what your main package is. One use case for which we introduce parameters. Another example is if you have a Docker file and you have args in there, then for the build, when you run it, you need to specify the values for those build args. And that's the story behind our parameter support that we added. So build strategy authors can nowadays define a certain set of parameters, can be single values, can be arrays, and build users can then specify the corresponding values for them. A nice feature that we have there is that those values can either be directly specified or they can reference a config map or a secret, so that you can also reference credentials from there, depending on the scenario. Another feature that we shipped just last week with our 0.10 release is volumes. And that's actually a great enhancement. I really like it. So, I mean, we all know it. When we build something, it takes time. If we rebuild something and we do it locally, it typically gets fastest because compilers reuse some of the things that it compiled previously if code wasn't changed there in certain packages, etc. Or if you think about a Docker file-based strategy, then layers, if things were not changed in the sources, can be cached and do not need to be rebuilt. And for that, we now introduced volume support. So build strategy authors can define certain volumes, and they can define them as overridable, and then the build user can plug in a persistent volume to make use of it, and then potentially, depending on the strategy, the builds get faster. We actually, so far, for last week's release, only enabled the KO build strategy, but it's just amazing to see. So if we build with KO our own Shipwright build controller, then the first build takes 1 minute 40 just for the compilation step, and the rebuild is then done in 2 seconds. I mean, that's how Go Cache actually works. And it's nice that we can now exploit this also in Shipwright builds. The second feature that I'm having here, and Enrique mentioned it already briefly, is local source support. So traditionally, we were able to load the source code for the images that you want to build just from a Git repository. But we recognize that as a developer, you do not always want to push every single change when you are iteratively trying something out to a Git repository just to run then the build. So what we enabled is local source support, and that's a really cool feature that I'm going to show in a moment. After I'm saying, obviously, there's way more features that we added in the past year. I'm just mentioning 2 of them. So we enhanced the status of our build run resource. You can find now there the SHA of the commit of the source that was built. You find the digest of the image that was built. In case of errors, you see fine-grained error details if the build strategy author takes care of them. But I mean, that's the dependency. But we are now able to propagate them right into the build run status so that you do not need to look into the logs for every kind of failure. Another thing that is really interesting is build run retention. So you can now configure your builds to only retain a certain number of successful and failed build runs. By coincidence, I stumbled over, well, actually for the first time used cron jobs a few days ago, and I noticed that they have the very same settings also. But on top of that, we also support TTLs. So you can define that a successful build run should only be retained for 24 hours, while you want to retain a failed one for a whole week for debugging purposes. So that's the retention thing. Let me come back to local source support. So let's try the video approach again. So we are on the command line, and we are switching into the directory where also the build is pointing to remotely that we previously created. And we are running a little set command that just changes a simple statement in the code. And then we are using the shp build upload command, again with the magic ---- follow flag. And now the build one is going to behave slightly different. So the build one is instructed to actually wait for sources to appear. And sorry again for this problem, but let me just continue. So the build one at some point comes to the source step where it doesn't clone the source anymore. Instead, it is going to wait. And now the CLI is going to stream the sources into the pod. What it technically does under the cover, it uses what you know from kubectl cp or kubectl exec. It basically copies the sources from your local machine into the running container and signals the container that it can continue. And from then on, the build run will progress as normal. There's one downside in that approach, and that is that you require the permission to do a kubectl exec. Certain administrators might not want to give you that because, I mean, in production systems, it would enable you to make modifications to also application pods or so, which you might not want to allow. Because of this, we are actually supporting an alternative approach for local sources. I'm not going to show that now, but it basically works like this. The CLI is going to package the source code into what we call a source bundle, and is going to push that into a container registry. And then the build one is going to pull it from there. The image is not runnable, it just contains the source code. So the running build one pulls it from there, extracts it, optionally deletes the source bundle container image from the registry, and continues. Obviously has another caveat. You shouldn't be doing that with a public Docker Hub repository because your source code would then land there. But if you use an enterprise container registry with fine-grained access control, then it's a perfect fit to stream, or actually not really stream then, but get the source code into your build run using this approach, because then it's still safe. So let's have a look at the roadmap. So one cool feature that we are working on at the moment is what I call image post-processing. So when I describe build strategies, and Enrique said quite similar things, then I usually say a build strategy defines the steps to turn source code into a container image. The reality these days is actually a little different because the build strategy also needs to take care of pushing the image to the container registry. The downside of that is that Shipwright didn't have any handle on the image. And now we are going to change this. So we are doing some slight API extensions, and then build strategy authors can basically just build the image and store it in the file system. And then Shipwright is going to take over and push that image. This alone doesn't have too much value, add to the users, but it enables the scenarios that I'm listing here. So we will be able to do a vulnerability scan of the image that you just built even before it gets pushed, so really the earliest time. We are looking at creating software bill of materials for the image with all the content that is in there. And we are also going to look at signing the image. And I mean, security and compliance-wise, that's all really interesting topics. Enrique also mentioned the triggers project, which is quite brand new. So as of today, when you want to get a build run going, you need to create a build run by yourself, either kubectl apply with a manifest or using the magic CLI commands that I had shown. But as of today, there is no automatic way to get a build run started. But we see many scenarios, and we are going to tackle that. So with the triggers project, we are going to enable integrations so that a build run would automatically be triggered when you push a commit to your Git repository. Makes highly sense. Another scenario that we look at is to start a build run when a build run of another build completed. Think of that you build your base image. You have one build which builds your base image, and then you have several microservices where you build your application images that depend on that base image. So when your base image build finishes, you actually want your application image builds to be restarted so that they pick up the new base image and leverage it. That's the scenario. Finally, Enrique mentioned that we are based on Tekton, and we are also looking at better integrating with Tekton. So in Tekton, there's a concept which is called custom tasks, which you can have in a Tekton pipeline, which means that one task in there is implemented externally. The corresponding concept there is also called a rundown at runtime. And we are going to provide custom task support so that basically a build becomes part of a Tekton pipeline. A really nice integration to basically make the picture a little bit more complete. Another sub-project that we started is the image sub-project. And that actually extends the scope of Shipwright. So far, we always end when the image got pushed to the container registry. With the image sub-project, we are going to take care of the container image even further. So with that, the image will become a first-class resource that you can create in your Kubernetes cluster. The first scenario that we are enabling is that we are mirroring the container image into a locally available container registry so that you can then further use it in your deployments, jobs, cron jobs, whatever. Has two scenarios. One is a locally available registry is probably faster in getting the image pulled. And the second scenario is that you then do not need to provide the credentials for your container registry into all your Kubernetes namespace, because you then just need to access the locally available, the image that is locally available from the local registry. Then we think about continuous scanning. So, I mean, I mentioned that we are going to do a first vulnerability scan before we even push the image. I mean, we all know that's not enough. Operating system libraries become vulnerable. Code dependencies become vulnerable. So you actually need continuous scanning for vulnerabilities. And with the image sub-project, that could become possible so that we continuously rescan the image to see if in the meantime there's a vulnerability in it. And maybe we eventually then just trigger a new build run to get it mitigated if it's in some of the base layers. And yeah, that's also a scenario. So one of those images could also be one that you didn't build with Shipwright. It could be your very base image, Alpine, Ubuntu, UBI minimal, whatever. And when that gets updated, you could then trigger a build run which consumes such an image. All cool stuff.
All right. Thank you, Sascha, for the nice deep dive on the next common things for Shipwright. So we're almost done. I would like to do a call for action. We would love to hear from you. You can find here to the left different ways of reaching out to us. We are in the Kubernetes Slack under Shipwright. We have a mailing list for users, and we also have our community call every Mondays. So you can just go and just listen. You don't need to engage if you don't want.
Let me just add, we have a website. It's not mentioned here, shipwright.io. So that's probably the easiest thing to remember and find those entry points.
One of the most relevant things is tomorrow we're going to be running our first official Shipwright Community Summit. So I encourage you to scan the QR code. So there you will find more information on our website. But it's going to be between 2 to 5 p.m. Local time, CDT. And it will be in room 209. For the folks attending virtually, on the website you will find a link to the Zoom session for tomorrow. Right. So with that in mind, I would like to conclude by thanking you. I know that it's quite late today, so thanks for sticking with us on this session. And now we're open for any sort of questions that someone may have.
Andrea?
Yes, so thanks for the presentation. I'm curious about...
You are going to get a microphone, 1 second.
Okay, so we have a question from Andrea from Tekton and CD Events.
Otherwise, just speak loud and we'll repeat it for the virtual attendance.
Yeah, I was curious about the triggers functionality that you mentioned. What kind of triggers you support, and if there is any relationship with the trigger
Okay, so the question was which kind of triggers we are going to support and if there's a relationship to the already existing Tecton Triggers project. So we had long discussions in the community, also a long time ago, whether we should reuse Tecton Triggers, but we concluded that we wouldn't do that. So we are establishing our own triggers project with inbound webhook to receive, for example, events from GitHub, and with a controller that takes care of other scenarios. And yeah, I mean, the triggers that we have in mind, they were actually listed. So we are thinking of, first of all, events that are coming from GitHub. We will not blindly support everything, but be very opinionated as we are usually in our APIs. So what we think makes sense is that we react when a commit is pushed to the branch that the build is configured for. We think it makes sense if there's a pull request open for that branch to react. Obviously, you will be able to define what you actually want as a trigger in your build definition, but we won't react on creation of an issue, for example. So, I mean, it will be those events that we think make sense. Obviously, if you have scenarios that are reasonable, just come to us and tell us. We can always extend. So the other thing that we had in mind is what was mentioned, when one build run completes, another one should get going. If you have such a chain where base images play a role. What was the third one I had on the list? You don't remember? Ah, perfect. Okay, he didn't listen. The Triggers project will also take care of that custom task implementation, so that we can become part of a pipeline. And yeah, the thing which I mentioned under image, also that is not really defined at all because both projects are new, so that's just existing as an idea. So basically, if an image that is managed by the image project gets an update, that the build run can be triggered. Go ahead.
Is the multi-architecture support? So I can build a Docker image for AMD and REM, for example?
For Arian, can you repeat it?
REM and
for ARM. Okay, yeah, so it actually depends on the tool that you're using, meaning which build strategy you use. As of today, in our sample build strategies, we are having 2 build strategies which are supporting cross-platform builds already. Those are BuildKit and KO. On other strategies, it always depends on the tool. Like, I mean, if you're using Canico, you won't ever build an ARM image when you're running on AMD 64. But obviously, if Shipwright, your Kubernetes cluster is running on ARM 64, then Canico will also build an ARM 64 image. A support that we don't have is, I mean, you could theoretically have a Kubernetes cluster with a mixture of nodes that are on different platforms. So we don't provide any selection as of now that you could specify, hey, run this build run on a node which is ARM 64 and another one on AMD 64. So that's something we don't have at the moment. But very good question.
All right, so I think we can adjourn the session.
Yeah.
Thank you. Thank you, folks.
Thank you. And I mean, we hope to